Here we have a velocity time graph. We have velocity on the vertical axis and time on the horizontal axis. If we consider the motion of a particle shown here, it starts with a speed of 0 and accelerates until its speed is 10. The gradient of this line gives us the acceleration of the particle along this section. To work out the gradient, we can see that this line has a width of 10 and a height of 10, so the acceleration is going to be 10 divided by 10, which is 1 meter per second squared. This makes sense because over the course of 10 seconds the particle goes from 0 meters per second to 10 meters per second, so it stands to reason that it picks up speed at the rate of 1 meter per second squared. Along this section, the particle has a constant velocity of 10 meters per second. The gradient of this line is 0, which indicates that the particle is not accelerating along this section. Along the next section, the particle is decelerating back down to rest. It loses 10 meters per second in speed in the space of 20 seconds. The gradient of the line is the acceleration. Here I've called it d, and the particle loses 10 meters per second over the course of 20 seconds, giving us an acceleration of minus 0.5 meters per second squared. Another feature of a velocity time graph is that the area under the graph gives us the distance covered. Consider this triangle. It has a width of 10 and a height of 10. The area is a half times 10 times 10, which is 50. Here we have a rectangle of width 20 and height 10, so the area is 200. For the final triangle, the width is 20 and the height is 10. A half times 20 times 10 would give us an area of 100. Therefore, the distance covered by the particle during this motion is 350 meters.